Hey, what's up guys? So welcome back to a brand new video. Today we are going to make a small clicker game, so you can just click and then this boy right here will actually go and move around. So right now I've got a very simple scene and there's only just one script running. So as you can see, if I click on the crown, then the boy kind of just teleports there. Obviously I'll show you guys the script in a while, but this is like the main game so far. So what we want to do first is build upon the script. So here is the script. So this is the player movement script. Here, as you can see, we have a little variable, camera animator, a world key for the animation, as well as our NavMesh agent, and this is all assigned in the editor. On void update, what we are essentially doing is we are checking if we press the left mouse button, If we did, we take the mouse position, we pass it through the camera screen point to ray, so this gives us a ray, and then we can just shoot a raycast using physics.raycast. We pass in the ray, and then we just out hit, and then we can just access hit that point to transform the position of our transform. And then set is working. We'll take a look at this later on. Alright, so now that you've seen the script so far, let's try and add the NavMesh component on this here, and then we can just start making the animations work and have the actual player move around rather than just teleport around. So a very easy way of doing the NavMesh would be to either create a blank game object right there, and then just have it move around this game object. It would be transparent. Or what you could do is create an empty, just call this NavMesh surface, like so, and then just have the NavMesh surface. Before that, let's not forget that we need to import the navigation package. Let's just find the navigation package. Where is it? Unity registry. No, AI navigation. So I'll install this and so now that it has downloaded, we'll have the NavMesh surface here, which we can add, and we can tick generate links. And here, what we want to actually see, or check rather, is the use geometry. This is important because now we can just have physics colliders be the geometry for for all the navigations in our game. So if we hit bake, as you can see, now it will generate the navigation surface for this. As you can see, it generates it, and all of it is good. So now what we can do is check. Okay, so it has, all right, good. And you could always tweak the values. For instance, you've got the voxel size and the tile size. You could also build the height map if you want, which can be useful if you're going on multiple islands later, or even just using this ladder. But right now this is where we are. So we've got the navigation surface already baked. Now we just need to set up the guy component. So use the NavMesh agent, and we also need a collider on this guy. So we can use a box collider for this one, right? And I just ensure that our collider is actually perfectly aligned. So we'll take it here, we'll take it from his foot, and then we can just do this here, and then here. Let's just put it here and here, like so. This should be good. And we can just keep that here, and we also need a rigid body set to kinematic. Alright, so now everything is ready to go. Now let me just update the script so that we can call the actual movement, so we can see the guy move instead of just teleporting around. So I'll be right back and I'll show you guys the script once it's done. So here we've added the NavMesh agent as well as the max distance. These are the two new variables. And on void update, what we are going to do is leave everything the same. However, on physics raycast, what we want to do now is reset the path. So this means that if the agent was moving and we click somewhere, the agent's path will get invalidated, and then we can just call set destination. We pass in hit.point into the new method get position. This takes in a vector-free position, and then we just calculate a NavMesh hit. We sample the position, and then we return whichever position is the best. So what essentially this does is it basically checks whether or not the destination is accessible to this NavMesh agent. If it is, then we just return position. If it's not, we return the closest position inside the NavMesh. So that's about it. Yeah, so here we are again. Now I just basically added the preference, the agent, and now if we hit play, we should be able to move the player where we click. So if I click it here, for instance, as you can see, the player kind of just moves there. If I click here, again it just goes there, right? As you can see, it works. And now if I click anywhere outside the NavMesh, the player simply cannot go there, so it will find the closest place, all right, on the NavMesh still to go. So for instance, if I hit this one, then the closest spot would be over here. So as you can see, it just goes there. Great. So now let me just add these as colliders, as obstacles, sorry. So the easiest way to do is to just come here and then just add a NavMesh obstacle like so, and then we can hit bake on our NavMesh surface, and it should technically work. Let me just add a collider on each one as well. Here you go, and then ooh, okay. Alright, so the colliders are not aligned, so I'll just fix the colliders and then I'll just come back. So a quick note guys, the reason I put the colliders is so that I can actually see the sizes before committing. So as you can see here, this is the collider, I can resize it, and then based on this collider I will know if the NavMesh obstacle is perfectly aligned. But once this is done, I can just remove this. Alright, so I basically just repeat the steps for everything. And look at this flower, for instance. Now I can see the box collider taking this proper size, which means that the NavMesh obstacle as well should take the proper size. So I'll just repeat this for everything and I just come back, alright? So for instance, here it is. As you can see, the NavMesh obstacle is actually here where the box collider is. So what I can do is I can just use the box collider and just resize it, for instance, like so. I can just resize the handle like this and position it well, like this. And then I can just copy and paste the center and size over there. And now, as you can probably see, the NavMesh obstacle is quite good. Obviously, there might be some size difference, but this is very easy to just rectify. But you've already gotten the position perfect, basically. So now I'll just remove the box collider from the remaining places, and I'll just resize and reposition the different obstacles. So here we are guys, I've already clicked bake after I've added the obstacles to everything. So now, hopefully our agent should technically avoid the tree. As you can see, it avoids the different obstacles. It will not go through them. For instance, if I click here, as you can see, it avoids the stone, or tries its best to avoid the stone basically. And yeah, so now it works. Great. So the reason why it's a little bit lagging here is because of this. So obviously, if you really want, you could technically adjust the settings of the NavMesh and the agent as well, so that it can also go near the edges a little bit further. But for today, we are going to let it like this, and then we polish it later on. So yeah, so that is about it for this part. And I'll also, I'll just make the animation, and then we'll end up today's video. And then in the next episode, we are going to see how we can have him interact with the world in a very intuitive way. So here is the player object. Let's focus on it. Select it here. This is the player, and as you can see, we have an animation controller already on it. So if I just take this off and I open the Animator window, this one, and then for the puppet kit, alright, here it is. Okay, so the controller was not attached. Alright, no worries. So now that we have the puppet kit, here is the animator. We only have the idle animation. So if we play it, then hopefully you should see the kid actually play an idle animation. As you can see, it's idling. So now let me just add another state. This other state will actually be for the walking animation. So let's find the walking animation. So we've got all the animations. Yeah, so here it is, the animation. So this is the idle, jump, test, run, depose, and walk. So we'll just find the walking animation and just drag and drop it here. So now what we can do is hit parameters, and then here I just have a boolean called this is walking, and let's copy the name. Alright, copy the name and paste it here. In the puppet kit we have the walk key, so just paste it there and save the scene and head back to the animator. Here what we want to do is a very simple state machine. So for now, because we only have two states, what we can technically do is have idle as a default, and then create a link, a transition from idle to and from idle. Make transition, and then make transition back, and then here for this arrow, what we want is walking to true. And for this one, is walking needs to be set to false for it to actually work. And now, what we have to do is actually very quickly change something in this code, and this is to this one. So a very simple thing that we can do is just call this like so, and then just feed in agent.isWalking. Is stopped false, but obviously this might not be very robust, obviously, but for today's use case we are just going to stick with is stopped, just to see if the animation works, and then later on we can add a proper handling there. So now let's just head back to here. Instead, let's just have it agent dot velocity dot square magnitude is greater than 0.5. Okay, let's just have a threshold. So if it's still moving, basically, then we can just apply the running animation or the walking animation. And let's just test this out and see if this works. Okay, that's a little bit weird. It should technically work. Alright, wait, let me just try and see what. Yeah, actually, I forgot to actually use the key here, so as you can see. And also, I'm just going to delete this and instead just have it set to this one, like so. Now it should work. So what was happening is I've actually added the walk key there, but I accidentally hard-coded the string. So obviously our key is different, as you can see. So that's why it did not trigger the animation. So now, as you can see, it works, but there is a small delay. As you can see, now it doesn't work and now it works. The way to fix this is actually quite simple. Here, what we can do is instead we uncheck has exit time, and we can also uncheck the fixed duration and repeat this to here. And now it should be much faster, as you probably can see. The animation sets in faster, but now the turning speed is a little bit slow. It's too slow actually, and we can fix this by coming here, and we can actually increase the angular speed for it to turn faster. Let's have it as 1500, and now it's a little bit better. Great. So now let's focus on actually making the foot actually sync with the animation speed. Right now it does feel like the character is kind of floating. Alright, so let me fix this in the code and I'll show you the code. And here is what we've changed. So what we changed is basically added the ease walking. We added the animator.speed equals to the agent.velocity.magnitude. This allows us to dynamically change the speed of the animator or the animation playing based on the velocity of our NavMesh agent. That's basically it. Alright, so here we are. I basically added only one line, as you probably have seen previously. So now if we hit play, you can probably see that the animation is actually way faster and it's also more grounded. Wait, I forgot to actually apply the turning, the angular velocity. Right, so now let's see if this works. So as you can see, the speed of the animation is actually synced with the speed of the agent. If we were to, let's say, decrease this to 0.1, then you should see that the feed also takes more time to play, so the animation just slows down. And if I were to increase it to, let's say, 10, now you can probably see that it becomes way faster and it's just way better, right? So this is part 1, guys, of today's video, and in part 2 we will try and polish this a little bit better and have some more interaction. Maybe we can have it chop the wood or gather stones or maybe gather something here. And yeah, we'll also see how we can use the ladder to have the agent actually move up the ladder to his house. So yeah guys, so this is all for today. If you guys found this video helpful, please be sure to leave a like, subscribe if you have not already, and also you can comment down below in the comment section if you've got any suggestions, queries or issues. I'll be very happy to help you. On this note, I'll see you guys next one. Bye.